Hello everyone. Welcome, welcome to today's presentation. I really appreciate everyone being able to make it here today. So let's start by basically asking, um, have you done? Maybe you have completed your education in software engineering, computer science, or computer engineering. You have been taking a training on some specific area like data engineering, web development, design, UI experience, and you probably are wondering, what do you do next? What is it that you can do now? What are you ready to do in a real job or in a professional career? So if that's what you're wondering about, if that's your situation, hopefully after today's presentation, you'll be able to have a little bit more understanding and context about professional career and technology. So welcome to today's presentation. My name is Oscar Garcia. I am a software engineer. I've been working on um, cloud engineering, web development, data, and artificial intelligence technologies for a few years now, more like 20 years. I'm very passionate about building solutions and sharing my experiences with everyone. I'm an author of the book called Data Engineering Process Fundamentals. This book is really specific to not just how to do data engineering with Python and how to understand cloud engineering, and but it has a focus on process, right? So process is really important. Once you start getting into your career, keep all keep that always in mind. The process, have a process oriented mind about everything you do, especially software development, software engineering. And that's what I attempt to do with this book. Just try to explain that concept and use technology to help you. If you there is a code there that you can scan with your telephones, that will take you to my contact information. I share a lot of GitHub repos there that have a focus on artificial intelligence, data engineering, web development, and the purpose of those repos is to really give you more of a real life experience about projects that we're doing and have also understanding about those specific areas. Okay, so let's get going here, right? So you're done with your tech career, with your education in computer science, what have you, right? And you're thinking, what do I do next? What's going on? What kind of job can I get? So everybody goes through that, right? So the hope is that you understand one thing, that learning never ends. When it comes to this industry, learning never ends. So whatever we learn is not enough, right? It gives us a concept, it gives us a foundation of what to use and how to do some level of programming and understanding, but it's not enough to really get a real job. So never stop learning. So always improve your technical foundation, your hard skills, right, in the areas that you would like to work. So for example, it's very important to understand the technical landscape. That means, stay informed with the latest trends and advancements in technology. For example, artificial intelligence, cloud engineering, those areas are really hot right now. They're trending. So it's kind of important to understand what that is and what is it that you can do with it and what skill sets are required to support that type of work. Also understand that maybe you right now, what you know now will change tomorrow. So you may have an understanding of what you want to do right now, but be open to the possibilities that can. So look beyond the area of a study and kind of focus on other possible fields that you may not know about today, but that may have a very solid future for you. So be open minded, continuous learning, always, never stop, right? So always look at what's current. Certain technologies in this industry, certain technology is hot today, tomorrow is not, and that is very true when it comes to areas like web development, where you have a lot of frameworks that come out. You probably are familiar with like React and Angular and things like that. So Web development is very dynamic. It just changes so often. So you need to be up to date with the latest technologies, right? And keep learning all the time. So always focus on very good technical skills that are on demand. So right now, cloud computer, data science, cybersecurity. You may not know much about these areas, but it's important to understand that. And you just need to kind of understand, learn it, and kind of figure out a path for you, right? So what you see here on the screen, for example, is a GitHub repo, right? And this platform is really good for us to continue to learn, right? So once you have time, now you can go to GitHub, visit some repos, and kind of use that as a learning platform, so you can understand really real hands-on programming process and the different type of technologies, whether it's data engineering, web development, AI, and what have you, right? So this image here is showing a data engineering project that I published in GitHub um, that I think is very useful when it comes to learning, because it shows you a process-oriented approach at doing data engineering, which is also applicable for some of the different areas in the industry. Also, in addition to the technical skills, right, we need to improve our strong skills, develop strong skills, right? These are very essentials when it comes to a real workplace, right? So we need to actually get involved and start networking and try to develop a professional career, right? And grow within your professional career. So how do you do that, right? So the thing is, how do I do that? It's not just a job, right? Don't think it's just I'm gonna be hired by some company and they're gonna help me do that. You can be proactive and start joining networks, right? So you can join networks through meetups and co-camps, SQL Saturdays, meet people, go visit, go see presentations, whether it's online or on person or on site. So, but it's important to build your network, understand what the industry looks like, and who are the people that are working, right, and understand and communicate with them and talk to them, right? So invest on improving your communication, right, with them. Improve your teamwork. Understand that even though software engineering is something that we often do by ourselves and we kind of focus on working on that computer, there's a concept of teamwork, and you will see that in real life where actually everybody contributes. So understand those areas, right? And problem solving skills. Be proactive. Don't wait for someone to give you a solution. Try to figure out and have a process-oriented approach to solving problems, and always communicate once you hit a roadblock or you don't understand, because we all have limitations in certain areas. So we probably need to have communications and talk to our teammates, be able to ask questions, and throw ideas and kind of solve issues, right? Find a tech mentor, right? Find someone that has more experience in your area or in that industry, and talk to them. Ask them, hey, what do I do? How does this work? What do they ask for? What do I need to learn? And kind of get that guidance, right? Because everything is specific to that area, whether it's an industry or whether it's a technology. And it's good to talk to those people, to experts on those areas, to be able to sort of understand what is it that is involved in that particular area of expertise. So in addition, right, once you understand technology and your soft skills, you need to kind of build out your career roadmap. What does that mean, really, right? What are we talking about here? So we may not have a clear understanding of what to expect, but sometimes there are opportunities out there that come up, and they are available to you, but we may not really understand what those career opportunities are. And we need to be open-minded when it comes to those opportunities, right? So for example, I hear this a lot. I hear a lot of people saying, I want to work for a big company and I want to relocate, right? I hear that often, right? So it's a great opportunity, right? Working for a company like Google or Microsoft is a incredible opportunity, right? But always keep in mind that not everybody's going to get those opportunities, right? Because there's so few and there's so many people that are applying for those opportunities. So always kind of choose your work preference, like whether it's remote or you want to relocate and work for that opportunity. But keeping in mind, do not waste an opportunity, right? So if you have, for example, if you want to, you don't want to relocate and you just want to work remote, but you have a very good opportunity that it requires you to relocate, assess that opportunity, right? Don't ignore it. Don't think, hey, no, I'm gonna wait for something that's gonna fit for what I want to do. Excuse me. So keep that in mind, right? So always open-minded. Of course, try to do what you want to do, but always keep an eye open for opportunities that you may think, I don't want to do this now, but it may end up being a great opportunity. I can tell you personally, that happened to twice in my career. I had opportunities that I thought were not what I wanted to do, and I just something told me to go for it, and I did. And now I feel that those two were two of the best companies I work for. So and with that being said, it doesn't mean that it's gotta be a big company, right? It could be a small company too. So don't get caught up in thinking I want to work for Apple or what have you, right? So if you do get an opportunity like that, is great. But if you get an opportunity with a smaller company, evaluate it. Have the opportunity to at least get through the door, and get the experience, because that's important. Once you get the experience, that is worth a lot. So, and you could spend maybe a year or two in smaller companies, gather more experience, and be better equipped to apply for a big company. So just kind of assess that and kind of through what you want to do and how you want to approach, but have an open mind. That is key, right? Also think, what is the industry you want to work for, right? In my case, I have worked for healthcare software technologies, and I have enjoyed that. I felt that those technologies, that the systems that we were building, were making a difference or are making a difference now in healthcare. So I felt that I was doing something very important. So I really appreciated that. So you just got to find the spot where you think you have value, right? You feel you're gonna enjoy, right? In addition to working and enjoying the technology, you're gonna enjoy the actual product that gets created for that industry. So you can look at other areas like manufacturing, sales, finance. There's so many out there. All you have to is kind of think, where do I want to be? I tell you personally, with artificial intelligence today, I mean, all these industries are just booming. Manufacturing is booming, healthcare is booming, because many things we used to do before, that it took a lot more effort to build, with AI is a lot faster to build, more efficient, and it opens up the opportunity to create startup companies as well. Because now, with AI, you can build something that before it required you a whole team to build. Now with less people, you can build more, basically. So it's a great, great opportunity now for that. So with that being said, we have to be able to also be familiar now of what do I want to do, right? So do you enjoy building websites, right? And what is a website, right? Is it a static website? Is it dynamic? Is it an e-commerce website? We have to think about those things, right? Do you want to build mobile apps, right? Do you want to build a new TikTok or a game on a mobile devices, right? Or do you like to do more like enterprise data analysis or data engineering, or data visualization, to kind of understand what the data tells us, right? Which is very powerful these days, right? Data is very important. So data science may be the thing that you want to be able to do. So it's kind of important to sort of understand the industry and understand the areas of specialization that are available to us. So I'm going to cover a few of them today that are very important and that always have a sort of a cross domain uh, um, function. It actually, like for example, you couldn't do AI system or application if you don't use web, for example, or if you don't use data. So a lot of these areas, right, they actually coexist together when you start building a solution, right? But to its own specifics, web development is really building a website, right? For web applications, things that are going to be running on a browser. And in addition to that, they can run on a browser on a mobile app as well. So, and a lot of these mobile apps are actually web applications running on what's called a browser component, which is just rendering the website on a mobile device. So understand that fusion of things, right? That you are actually thinking I'm doing mobile development, but in fact you're doing web and you're doing kind of a hybrid implementation. But mobile development is also specific, right? If you want to do what's called a native application, where you're actually building like a true application that uses components that are specific to that domain, right? So it's not a web component, it's actually a native component for mobile development, right? Areas like data engineering is important, it's huge important. Without data engineering, there is no AI. The foundation of AI is based on a lot of data, right? Data that they through algorithms, machine learning algorithms, they have developed like large language models. In order to be able to do that, you need data. So data engineering is a foundational component of this artificial intelligence, right? So, and it really the focus there is to build solutions to get the data from different places and transfer the data into data lakes, data warehouses, what have you, for machine learning algorithms to be able to process the data and create AI models. Data analyst. So data analyst really looks at this kind of information, lots of data, and understands the data and kind of does analysis and kind of figures out what is the data do. And in that sense, what that means is, are we, for example, are we selling more in Florida than in California, right? What are we selling? What is our hottest product? You know, what is the demographics that are buying our product, and so on. This kind of stuff is very common in all the technologies and all the different industries, right? Data science is the one that specifically focuses now on getting these massive amounts of data and building out these machine learning models, right? To be able to do predictive analysis, for example, right? So, for example, hey, we're we're noticing that our equipment is failing us so many months after started running, for example, general equipment and manufacturing. Through machine learning models, you can predict the breaking points of those based on previous data, right? So you need previous data to understand that. Of course, artificial intelligence, as I said before, is really basically you have creative AI or generative AI, which is based on large language models, which really help us develop context, whether it is a book, whether it's code, and many things, right? It's very, very important. But the way that will work, if we want to take advantage of that generative AI, we need to build an app. We need to either build a mobile app, we need to build a web app. They integrate with that AI model via APIs. And API is really is a way to communicate to backend systems to be able to get something, right? So you will say, hey, you will use an API, call that AI model and say, look, based on this input parameters, can you generate some context, or can you predict, give me a probability of something, right? So, but I want you to understand that even though we're saying AI, there are other things in place here that are working together, right? So cloud engineering, without cloud engineering, none of this runs, right? So where are the AI models being hosted? Where are the websites being hosted? What is the process for data engineering to extract the data, process the data? And what is the process for machine learning algorithms to execute massive amounts of data? All of that runs on data centers, usually cloud data centers, right? Whether it's Amazon, Microsoft, Google. So all of this is really the foundation of all of these technologies, and there are specializations on those areas that you can actually sort of focus and work for, right? So very key. Cybersecurity, which everybody's trying to hack everybody these days, so it's very important to be able to protect the system. And it's also, as a developers, have to be mindful that regardless of the specialization, you always have to have security in mind. Always, whether you're building a game, a mobile app, web app, you have to have certain standards and principles to be able to build this with security in mind. Okay, it's important. And of course, game development. You can create video games, especially now with. I used to work for a company called Magic Leap, and we used to. What we did is we did augmented reality devices. Um, and if when you develop games, a lot of these experiences are developed with sort of that approach for the augmented reality sort of feel to it. So that game development extends to more than just games, right? So it's very important to sort of understand all those different areas. And there are more areas here. I'm just kind of saying the most popular is here that you will hear about, but definitely there are a lot more areas, but it's hard to cover everything, right? So, but now that we understand, right, that there are different areas also, right? We know that we know that we can build web applications, mobile apps, and so on. But how do we build them, right? What is the process to do that? So, as you probably know, software development relies on a particular programming language, right? So, once you start working on some systems and applications or solutions, right, you're gonna have to work team, and they're probably focused on something specific, a programming language, right? And not every programming language can do everything, right? Those programming languages are unique. They have a unique syntax and functionality, and also they have a particular domain expertise where they're more reliable or they're more powerful to use than in other areas. So, for example, also here I want to point out that it's very important as you go out to get a career to understand what's in the market, right? What's out there in the market? What are the popular languages? Where are the most jobs available to us, right? So, and at the top you will find JavaScript, and JavaScript is is used for web development, right? For building interactive interfaces and hybrid mobile apps, as I said before, not native but mobile apps using frameworks like React Native, right? So if maybe you have heard about React, you have heard about Angular, right? Those are frameworks that enables you to build solutions using JavaScript language. You have Python, right? Very popular. Python has exploded in the last 6 years or so. It's a very friendly language, and that's one thing to point out too, is that why do they call it friendly language? And I'll touch a little bit more about that. But understand that it's very popular for data science, for machine learning and automation. There's tons of both JavaScript and Python. There are tons of libraries, tons of projects on GitHub where you can actually go and see and join and work on open source code projects for you to learn and understand how they're doing things, right? So Python is very, very powerful, very important. There are the older technologies like Java, right, which is heavily used for enterprise development, right? You can do a lot of things with Java: web development, backend development, mobile development for Android devices, and it is called a high-level programming. But what does high-level programming means, right? So, so high-level programming language means that it's a language that is even though it's kind of hard, it's harder to sort of understand it because of so many features. It still doesn't it protect us from doing low-level programming. And the difference is low-level programming, we sort of do more the memory management during the programming, right? So we deal with pointers, right, with memory allocation. All those things make the programming more difficult because you're not really just coding for a solution. You're coding for making sure that you're not crashing your software. So understand that level of difficulty as well, right? So Java is more difficult because it's also a object-oriented programming language, right? So it sort of forces you to follow certain standards, certain data type definitions, and so on, right? Same as C#, right? C# is another powerful language, a high-level programming language that is used for game development with Unity, with the Unity platform, web with ASP.NET, and it's great for enterprise applications, right? My expertise are more towards JavaScript for web, Python for data, C# for backends and systems, right? And SQL for database. So SQL is a is a scripting language that enables us to query a database. If you're familiar with databases, right? If you want to be able to select data from a particular table, that's where the records are stored. SQL is a script language where you can actually say something like select this particular fields from this table where I want every record to be from last year, for example, right? So it's a very powerful language that is used, very popular, very widely used, right? So often you'll see Python working with SQL, and the way that works is that Python will be a scripting, is a programming language friendly that doesn't have a lot of this object-oriented concepts. It's very dynamic data type, just like JavaScript as well. That's why it's kind of friendlier, because you don't have to follow this constraints of the programming language. And the concept here is the constraints of the programming language, meaning some languages are so rigid that you spend more time sort of understanding the standards, right? The syntax of the language. And so that, in a way, for many, it takes you away from thinking about building solution as opposed to focusing on syntax of the language, right? So what that means is it gets to a point in some industries that they just want the solution. They don't want you to be studying a particular syntax, that sort of thing. That's why JavaScript and Python languages are very popular, because you don't have to worry about so much of the syntax. They're very friendly languages. But yeah, when it comes to Python, then usually you're going to be working on solutions where you're actually doing Python scripting to do data translation and things like that. And SQL be embedded within some of the Python scripts to be able to extract the data from the data source base. So they work together a lot. Also, you have PHP, particular another platform or framework to be able to build web solutions. And you have a C++, C, which are high performance languages for system programming, right? Game development and scientific computing. These are the languages that are used when you're building a low-level system, right? When you're building a system that needs to perform. Now, this is even beyond a lot more difficult than Java and C#, right? Because now here you're dealing with pointers, with memory management, right? So you need to be very, very careful. So the syntax here is twice as more difficult than C# or Java, right? Even though C#, C++, C have certain similarities, the level the level of the learning curve is a lot steeper when it comes to C++ and C, just because of the difficulty of memory management, right? Which high-level programming languages protect you from having to worry about. You have Swift and Objective-C, which are the preferred frameworks to be able to build iOS development for Apple devices. That's another thing to think about, right? So if you work specifically for iOS, that's the only device you're going to work for, right? If you work for more open platforms like Android, web, then you can build across devices. So it will be what's called platform agnostic. If you build a solution, a mobile app using like React Native, that can work across platforms. It will load on Windows, on web, on iOS, on Android. So keep that in mind. Cross-platform development is key, because that opens up more doors, right? Oh, and TypeScript. So TypeScript is a superset of JavaScript. So as I said before, JavaScript, Python are very friendly because they're dynamic languages, meaning you don't have to define the data types, right? It's freely, you can just kind of create variables without giving it a data type, right? So, but TypeScript enforces you to do that. So TypeScript brings some of the C# features into the programming languages, and it's actually gaining momentum, because the problem is, once you start building a mature product, you know, when you're using languages like JavaScript, you tend to do a lot of shortcuts, and these shortcuts will eventually reveal themselves, right? You will have problems in the system. So for more mature projects, TypeScript's being used. So to force the programmers to be able to define their data, right, their data types, to be able to find certain standards and not be so free on doing anything, right? And so it's being used a lot. So it's bringing the concept of JavaScript into a more difficult level, in the sense that you need to understand syntax a lot more, right? So yeah, and there are more other languages out there. I'm just kind of calling out the most popular ones, right? But is everything about coding? Is everything really is just programming, or what's out there, right? So that's one of the questions: is my career going to be just programming, or are there something else that I could do? And the answer is yes, right? Programming, really, the focus on programming is to write code all the time, right? And that's where you live in, right? And you spend maybe 80% of your time there. But there are also non-programming tech roles, like project management, like QA, right? So this is for quality assurance engineers, user experience designers, technical writers. All these team members are very important when it comes to building out a solution, building out a project, right? So as you see here on the screen, on the image here, you will see this is typical of a team, right? And it's just not the programming role, but it's the project managers, the QA, the designers, the technical writers, right? The analysts, right? The system analysts also, right? So we all work together, and we all have a particular role, specific responsibilities to be able to build this out, right? So this is very common. So a lot of people may think, oh, so is my career, and this is true. This is a fact. A lot of people start programming, but they may find it that they don't like it. They want to be more in the management area, right? So they start gravitating towards project management, right? Business analysts, right? They kind of like more to work with a team management role, which really, where you actually are managing people, as opposed to when you are a programmer, you sort of focus more and you program more, or you manage more technology. You focus more on the technology aspect of things. Of course, personally speaking, in my opinion, the responsibility of a software engineer is everything, right? Software engineers is really not just writing code. It should be everything. Be able to write a specification, be able to write architectures, be able to understand the process of testing, be able to understand the process of deployment, all those different areas. If you gather that information and you are willing to accept that information, you will become a more well-rounded professional in your career, right? I often throughout my career, I have heard so many software engineers just say, just tell me flat out, no, all I want to do is code. I don't care about everything else. And that's the wrong approach. That's really the wrong thinking, right? If you need to, for you to be a very solid professional, you need to understand other areas as well. So, and what we know today changes tomorrow, right? So the industry continues to evolve, and there are more specialized roles that are being created, right? For example, 10 years ago, for example, developers had more of a, not just development, but they did a lot of roles, right? But as the project grows bigger and the industry changes, they specialize people. So, for example, they would specialize BA to do a specific area that maybe the developers used to do. So a BA is a business analyst, right? So what that means is you focus on understanding the business, how the business works, and you have expertise on that domain knowledge, and you translate that into programming. So later, the industry sort of split it out and said, look, we don't need the programmers to know the business. We just need a BA to sort of document everything the business needs and write the requirements for the developer to follow, right? Which to me, in that philosophy was a little bit wrong. I thought, for me, developers really needed to understand the business, and otherwise, how can you build a solid solution? So, but you will see that level of specializations and how the industry evolves and changes over time. But so what if I just want to focus on development, right? That's my focus, and that's all I want to do, right? So, well, development is not just coding these days, right? evolution of other platforms. For example, uh, especially also with AI. I mean, that has changed a lot. That is changing a lot, and this is true for a few years now. So it's not something recent, right? So, for example, do you like to do code all the time? As you see in this image, this is what you will do when you code it. You actually write in this sort of code, right? And this is for reference. This is a GitHub repo that I have, and the language you see there is C#, right? So this is what you do when you code, right? And it is fun if you like it. You know, it's fun. I enjoy doing software development. But it doesn't have to be just done this way. And it really depends on what you're building, right? If you're building a platform, if you're building something like a TikTok application, you probably will have to write something like this. But if you're building integration solutions, enterprise solutions, right, you probably will just use a low level development tool, right, that have visual they use visual tools for you to be able to design solutions, and perhaps maybe write a little bit of code snippets, right? So what that means really is that, first of all, let me just finish with code centric. When you're doing the code centric, you basically are writing code with Python, C#, C++, JavaScript, and you're coding, and you're submitting your code to GitHub, and you're building the code, and you're deploying your code, and so on, and you test it, right? So that's the software development life cycle for that. And it gives us full maximum control over the solutions. It helps us build the performance, the guidance, and everything. So, for example, like I said, TikTok app, then you build it like this. But it requires us to become experts, right? We got to become experts on the language, on the programming language, and on the domain, right? To understand how to build the applications with performance in mind, right? But of course, you can use also low-code, no-code development tools for enterprise systems. This is really heavily being used, right? So basically, what they do is you have, for example, the screen you see there, you have user-friendly platforms that enable you to drag and drop components, right? So this is Looker Studio. You can look out for Looker Studio. You can create a free subscription if you like data visualization. You can actually build dashboards like that, right? You can actually go ahead and create drop components, connect to a data source, and create your visualization, which is a heavy and popular market out there. Data visualization is huge. It's huge, right? So there are tons of jobs when it comes to that. So these kind of tools are very ideal for rapid development, rapid prototyping, and it's very friendly. So you don't have to. So you have to see if you focus on development, you focus on designer tools and platforms. Those are very important, right? So you don't have to be only coding, right, all the time. It's important to understand. It is also very important to understand that we need to evolve with technology, right? So the software development is always transforming. There are always new technologies, right? And like I said before, AI now is huge. No-code platforms are huge. Automation is incredible. Cloud engineering is booming. All these things are happening and evolving. And one thing that's constant is that we have to keep in mind that we must keep evolving as well, understanding where's our career going and sort of go towards that. Don't just stay, if I learn C# and I stay with C# all my career, that's not good. You need to adapt new things. You need to learn new things and keep on learning, right? So for example, AI, right? So a lot of people, oh, AI is going to replace programmers. Really, it's really not going to do that, because somebody has to program the AI anyways, right? So, but it could become a powerful tool to enable us to build code, to refactor code, to debug the code, to generate code that is very repetitive. So for example, select statements and some web forms like a login form and all that. All those things are very repetitive. We don't many of them. With AI, you can just say, generate me a login form with this kind of fields. By the way, if you're interested in seeing that, look at my GitHub repo on AI. I do have there an example of how to generate code with AI using Gemini or using ChatGPT or OpenAI. Also, you have low-code, no-code tools that are booming out there. Microsoft Power Platform is one of those where you can build include enterprise solutions with that. and it's really very low code, no code, right? Low code is when you write a little snippet, like a little function to do something specific, right? So, but those are very powerful tools, and you probably want to find out about GitHub Copilot. Read about that. GitHub Copilot, very interesting, free subscription. Download Visual Studio Code and use it, and you will see the power that it has. Right, automation. Right now, we need to kind of automate everything, automate solutions, code, data flows, system designs. Right, so we can create automations, and like I said, cloud engineering, the glue that puts all this together is cloud engineering. Right, building the infrastructure where everything is going to be running, the data lakes, the data warehouses, the data pipelines, the machine learning systems and models and website hosting and all those things. So cloud engineering is powerful. So with final thoughts, there's a strong future in technology. We just need to kind of keep learning, join communities, try to join like you're doing today, join in this presentation to get an idea of what I'm trying to do, right? What we're trying to figure out in life. Right. So be active, be proactive. Don't just wait for the job to land on your lap, but be proactive. Get involved with GitHub repos. Strongly suggest visit my contact information. I have good GitHub repos. I think personally. Also have my book there for process. If you can give the repos a start, that keeps the momentum going for those repos. But it's also important to understand what kind of industry you want to be in, right? Where you want to be. It's in finance, it's in health, it's in manufacturing. So to try to build that roadmap that gives you that understanding, right? And believe me, if you say today, I'm gonna do C# or I'm gonna do C++ or I'm gonna do embedded programming. I didn't even talk about embedded programming, right? Which is really is a very small sort of low-level programming approach for chips, microchips, and devices, right? But try to understand where you want to be and what you want to be doing. But then tomorrow, that's probably going to change. Just to be honest with you, your path may change, but it's not that it's going to change like because something happened. It's just going to evolve. So you may join a job today and you start doing maybe JavaScript or something else, and as you get more experience on that, you start evolving into other roles. Maybe you go into project management, maybe you go into team lead, maybe you go into dev management, principal engineering, right? So those things, your career will evolve, and then you may evolve from JavaScript into maybe Python because you're more focused on data, and so on, right? So just keep that in mind. That will happen, and always find a balance, right? Find a balance where it's not all about the job. Really, it's not just, hey, my life is my job and I do this all the time. Try to have a little bit of balance, otherwise you're gonna get burned out quickly, right? When I started my career, I was doing like 12 hours a day. Why? Because I didn't know anything, right? You come out of school thinking you know something, but you don't, because it's just really a baseline that they teach you. They don't really, once you get to a job, you need to understand the specific of that job, the specifics of the technology, the specifics of the domain and industry. So you need to catch up and you need to push yourself forward. But eventually that can impact you, and that can make you dislike what you do. So try to balance yourself. Once you feel tired, try to understand that it's not natural to work so many hours. So just keep that in mind and find a balance. So please stay connected. This is my contact information. If you happen to have questions after this presentation, shoot me a Twitter message or what have you. Follow my GitHub repos. Stay in touch. I'll be producing more material like this. Also, a lot of presentations on AI, data engineering, and web engineering or web development. So thank you so much for coming. And if you have any questions, we have a couple more minutes for any questions you may have. But of course, you can shoot me a question after. So let me know. You can use the chat or you can use the Q&A. Let me look at the Q&A. Okay. All right. No, thank you. Thanks everybody. I hope this conversation makes sense to you. This gives you like this window to see the inside of what's happening. And I hope this just really, the message you take with you is to be open-minded, right? What you know today will change tomorrow, and just have be flexible, open-minded, and kind of understand that you can branch out to other things. And don't get frustrated, right? Though, because I hear this a lot too. Hey, I took classes on C++ and I can't get a job on C++. Those jobs are really hard to get, very difficult to get, right? C++ jobs. But if you look at JavaScript jobs and Python jobs, there are a lot more jobs, a lot more jobs. So what you got to do now is say, I got to learn JavaScript and Python and kind of focus on what is it that's really trending. That's my message, and I hope you take that with you today. Okay. Thank you, everyone. Stay tuned. Follow the chapter. Follow me on Twitter, on LinkedIn as well if you want, and stay in touch. Okay. All right. So thank you, everyone. Take care. Bye bye.